Okay, now let's do the 10th. Now let's do the 10th problem, that is find the derivative of cos x using first principle. Okay, so we have to use the first principle of derivative to find the derivative of cos x. So what is the first principle of derivative? The formula, the f dash of x is equal to limit h tends to 0 f of x plus h minus f of x upon h. Okay, so this is the formula for the first principle of derivative. Now this is cos x, so f of x is equal to cos x. Now we have to find f dash of x. F dash of x is equal to, so putting the values of cos x in this formula, now x will be added by h. Okay, so we can write limit h tends to 0 cos x plus h minus, this part is over, now f of x, the function as it is. Okay, cos x upon h. Okay, now now you see we can solve this by using two methods, two formulas. Okay, if you consider this to be cos a, this to be a, and this to be b, then we have cos a minus cos b. Okay, which is equal to minus 2, what is the formula, minus 2 sine a plus b upon minus sine a plus b upon 2 multiplied by sine a minus b upon 2. Okay, oh yes, it's minus 2 sine a plus b upon 2 and sine a minus b upon 2. Okay, this is the formula. So we can expand this using this by this. Okay, considering this to be cos x, cos a and cos b. Okay, now we can do it in another way also, that is considering only this thing, this function cos a plus b. Okay, so okay, first we'll do this. Okay, then we'll try the other method also using that formula. Okay, now cos a minus cos b, let's expand this in this way. So it will be f dash of x is equal to limit h tends to 0 minus 2 sine a plus b by 2 okay, sine a plus, sorry, okay, it's not a plus b. Okay, we'll do it again. Okay, so f dash of x is equal to limit h tends to 0 minus 2 sine, now a is this one. Okay, x plus h, b is this one. Okay, plus x upon 2. Okay, multiplied by sine a minus b, now a is again this one, x plus h minus b is this one. Okay, x upon 2. Yeah, that's it, whole divided by h. Okay, now if you see, let it be like this. If you see, x and x becomes 2x, here this x and x goes out, so we can write this as limit h tends to 0, let's bring this minus 2 out. Okay, so minus 2, let it be here, so this becomes sine x plus x becomes 2x plus h upon 2. Okay, divided by this becomes sine h by 2. Okay, now you see this resembles a theorem in the limits of what is that, theorem of the limits, algebra of limits. Yeah, algebra of limits, that is sine x upon x, limit x tends to 0 is equal to 1. Okay, So if we bring an h by 2 here, so this will be in this form and this will become 1. So let's do that. Okay, so limit h tends to 0 minus 2, okay, sine. Now if we separate this 2 to both the denominators, split this 2 to both the numerators, 2x by 2 and h by 2, this 2 when you cancel it become x plus h by 2. Okay, multiplied by this will become sine h by 2 upon h by 2. So when we are multiplying dividing an h by 2 here, so to balance it we multiply an h by 2 here also. Okay, now we have an h here. Okay, well, let's bring this h out. Okay, if we bring that h out, let it be here. Now limit h tends to 0 minus 2 by h, and let us bring this h by 2 also out. Okay, so it become h by 2 sine x plus h by 2. Now this becomes, okay, sine h by 2 upon h by 2. Okay, now this h and h cancel, this 2 and 2 cancel, you only the minus is negative is left. Now let's take the limit inside. Okay, so it become minus 2, so not minus 2 is gone, no? Limit h tends to 0 minus sine x plus h by 2 multiplied by limit h tends to 0 sine h by 2 upon h by 2. Okay, so see, now this is in the form of this theorem, so we can write this as 1. Okay, h by 2 upon h by 2, h tends to 0. Okay, now putting the value of h in this function, you have minus sine x plus 0 by 2 multiplied by this becomes 1. Okay, whole thing becomes 1. So this becomes minus sine x plus 2 zeros are 0, sorry, 0 upon 2 is 0, and this is 1. Okay, now this becomes minus sine x plus 0 is x sine x. Okay, this is the derivative. You know that the derivative of d by dx of cos x is equal to minus sine x. Okay, we have learned this earlier, so this is how we derive it. Okay, now we'll use the other formula also. Okay, see, now see this, f dash of x is equal to limit h tends to 0 cos x plus h minus cos x, okay, upon h. Okay, writing this here. Okay, now we'll do, now we can take, see, considering only this thing, cos x plus h, this resembles a formula, it's a formula cos a plus b, which is equal to cos a cos b minus sin a sin b. Okay, so we'll expand this in this form. Okay, and put this now this is limit h tends to 0 cos x plus h will become cos x cos h, okay, cos a cos b cos a cos b cos x cos h minus sin a sin x sin h. Okay, now this remaining this one minus cos x, okay, upon h. So now let's bring this cos x to this cos x. Okay, we will write this together, so it will become limit h tends to 0 cos x cos h, this minus cos x, and remaining minus sin x, and so this is sin h. Okay, sin h upon h. Okay, now let's split this h to both Now let's take common out here. Okay, so limit h tends to 0. It's cos x common. Cos x common means it becomes cos h minus 1. Okay, minus sin x sin h. Now this h, let's split and give it to both of this h and h. Okay, so now you see sin h upon h. This resembles the theorem. Okay, the limits of derivatives, algebra of limits. Yeah, algebra of limits, you have this theorem, limit sin x tends to 0, sin x upon x is equal to 1. Okay, and also you have another theorem, that is limit x tends to 0, 1 minus cos x upon x is equal to 0. Okay, that is another theorem. Okay, in algebra of limits, if you have this both these theorems. So now we'll make this also to resemble this. Here it is cos h minus 1, we'll make it 1 minus cos h, so it will become limit h tends to 0. Let's take negative common here. Okay, see cos x, so negative common, then it becomes, this will become positive 1 and this will become negative cos h upon h. Okay, minus sin x and sin h upon h. Okay, now let's split the limit to both these functions, so it become limit h tends to 0. So cos x can be brought out, let minus cos x be out, so it become limit h tends to 0, 1 minus cos h upon h. Okay, this is one function, minus again here limit h tends to 0, let the sin x also be out. Okay, sin x, then limit h tends to 0, sin h upon h. Okay, now this thing becomes 1 and this thing expression becomes 0. Okay, so we can write this as minus cos x, this is 0, minus this is sin x left here, and this becomes 1. So this whole thing becomes 0, minus sin x into 1 is sin x, so we have minus sin x remaining. Okay, so minus sin x is the derivative of cos x. This is how it's done using the two formulas. Okay, that's it.